Okay. This is the technology section. Okay, science and technology section. Have you seen the syllabus? Okay, first tell me, this is the prelims oriented lectures. So first tell me one thing, who all have to appear in prelims, in this coming prelims? Okay. Others next year, is it? Okay, okay. So those who have to appear, okay. Actually this lecture of prelims is designed for the same, okay. But those who are supposed to appear by next year, or even I think next to next year, is it also? Okay. So for them, it is the case that you have again to attend the session of technology in detail, okay, that is in the regular batches, okay, that will be both for prelims and mains, have to again attend the same. And in that session, we'll be discussing about the mains and all, okay, about the mains answer writing and all, because the thing is that the answer writing of this section is very much different. It is not like other sections, okay, and is nowadays very much important, as somewhere around 15 to 16 question even comes in prelims, and around 6 to 7 question in paper third. Paper third you might be knowing is the title is technology, economic development, biodiversity and all, okay. So the thing is that, okay, one more thing, who all are from science background, that is who all are having science as a subject in graduation? Okay. Others are not having science in graduation. Okay, see. Others are, and who all are having science in till standard 12th? Okay, okay. See, the thing is that in the present pattern that was changed by UPSC for prelims in 2011 and for mains in 2013, they have included the technology section, and almost all the topics, subtopics of science and technology is there in the present syllabus, okay. Even the thing which is not a matter even up to BTech, something that is matter of MTech, PhD, that is of nanotechnology, higher things related to robotic technology, these all are included in the syllabus, okay. They are asking even the questions on the same lines, okay. They had asked almost all the basic questions, so even they had reached to such an extent that they are asking even the questions are very technical in nature. Like just I am giving 1 to 2, 3 questions that seems to be very general but is having very technicalities. Like you all have seen VOLT in your mobile phones, okay, LT, okay. Can you say what is LT or VOLT? Can you just define what is VOLT? Is the full form, okay. I am just asking the definition. Okay, or now you are getting the thing. Thing seems to be very general, okay. Every one of you just have this thing in your mobile phones, okay. Seems to be very general, but they are asking, they have asked the same thing in the prelims question. That too, I have just asked to you what is VOLT, what is LT. They have not just asked up to what, they asked the technicalities related to both LT and VOLT, and the statement that was there in the multiple options of 1 and 2, it was in the pattern 1 only, 2 only, both 1 and 2 and none, okay. The pattern was such that they have very intelligently made both the statements wrong. So you can understand one thing, they are asking the technical things, at the same time seems to be so much analytical that you have to judge whether it is correct or incorrect, and both the statement were incorrect. Just in the last prelims, they have asked about VLC technology, okay. We'll discuss all these things, but what idea I want to give you, that in the prelims, they have reached to such an extent that they are asking even the technical questions. They also know that there are many who are appearing, okay, are not having background of science, but they have still included the technology section, because today you can understand in each and every aspect of life, it is the technology which is the most important guiding factor. You can understand better, okay. And in the transition of India as from developing to developed, this is the most important thing that has to be there, okay. So this point is clear, okay. So the thing is that presently in both prelims and mains, they have reached to such a technicalities. Okay, so first I'm explaining you about the approaches for both prelims and mains. Okay, then I'll restrict myself to the prelims discussion. Okay, the rest discussion we will have in detail in the main section. This point is clear. Okay, first I'm giving you the syllabus. Okay, write the syllabus. I'm just giving you the entire syllabus of the technology that is mentioned in the UPSC syllabus. Okay, then I'll explain about the syllabus first, about both prelims and mains. Okay, then we'll move over the discussion. Okay, so write about the syllabus. First topic, write space technology. Space technology. Second topic, energy. Energy. Divide the topic energy into two subtopics. Okay, write in energy two subtopics. First, write nuclear energy and research. Nuclear energy and research. Oblique nuclear technology. In the same nuclear technology. And write the second one, NCE. NCE, non-conventional energy sources. Non-conventional energy sources. Oblique alternative sources of energy. Oblique alternative sources of energy. Next, third topic, defense technology. Defense technology. Fourth topic, ICT, information and communication technology. ICT, information and communication technology. Next, nanotechnology. Next, robotics. Okay, you have written 6 topics now. Okay, next write biotechnology, 7th one, biotechnology. Next, patent, write in bracket intellectual property right. Okay, intellectual property right, IPR. Patent in bracket IPR, that is intellectual property rights. And write the last topic. I have placed all the theoretical sections in this last topic. So write Government of India's policy in science and technology. Government of India's policy in science and technology. One more right topic. Achievements of Indians in science and technology. Achievement of Indians in science and technology. Okay. Now, this is the standard syllabus of technology. Okay. First, I am giving you the important topics regarding prelims. Okay. So, just have a tick mark in the entire syllabus. Important topics for prelims. Okay. First tick mark is space technology. Space technology. Then nuclear technology, that is nuclear energy and research. Okay. Put double tick mark. Okay. Double tick marks means most important, single tick marks less important. Okay. Then place a single tick mark to NCE. Double tick mark to space technology and nuclear technology. Single tick mark to NCE. Okay. Then double tick mark to defense technology. ICT. Next to defense technology, ICT. Again double tick mark. Okay. Nanotechnology and robotics, just place a single tick mark. These both are mains based topic. Okay. And biotechnology, double tick mark. Okay. Rest all patent and last topic is exclusively mains topic. Okay. So now you can understand one thing. 4 and 5 topics are such which is having almost 90% of the prelims question. Okay, the thing must be clear in your mind that what is the question area. If you analyze the entire syllabus of UPSC, it is maximum 60 to 65% of the syllabus that consists of more than 90% of the question. So as the competition is very intense, so you are supposed to have very specific to those topics which are having very much importance. Okay, now I am just giving you one idea regarding general science as well. See, in the present pattern, in the prelims, okay, it is both general science and science and technology. Okay, and in the mains pattern, it is only science and technology. This point is clear, that is general science is not there in the main syllabus. You are not supposed to prepare any subjective questions like somewhat like explain cell division. Okay, it was the case before 2013. They have changed the pattern, they have removed general science from the main syllabus. This point is very clear. That is in the mains, entire 9 topics which I have given to you is the syllabus. This point is clear. Now, in the prelims, in the entire topics, I have given you the most important. At the same time, general science is a matter of NCERT standard 6 to 10. Okay, all of you have studied till 10th. Okay, but see the way UPSC is asking the question from general science in prelims. Okay, general science is physics, chemistry and biology. They are not asking any direct questions since 2011 in the present pattern to till date from physics and chemistry. It means it is not the case that they are not asking physics and chemistry question. They are asking the basic questions of general science from physics and chemistry, but along with technology question. For example, all of you have heard about something called Chandrayaan-2. We will see in detail. Okay, Chandrayaan-2 is something like a space mission. What it is all about, we will see in detail. Okay, in a question of Chandrayaan-2, okay, the way of asking the question in prelims, I am just giving you one idea of the question. The present pattern is something like this. They used to take something from the contemporary aspect. You can understand, technology which is at present is having much more meaning than the technology which was in 1990s, which was in 2000. This is the nature of the technology. Okay, so UPSC experts takes the question from contemporary issues. Contemporary issues, why this word I am using? Because not to get confused with you like something like current. It seems like science and technology questions are coming from current. It is not the case. Okay, they are asking the thing. They have asked VLC technology just in the last prelims. It is a matter of 2015, but is a very new technology, matter of research that is even in the present day. This is clear. So they used to take the things which is in the contemporary aspect. Chandrayaan-2 is a matter something of 2019. Okay. Now this is the present pattern 1, 2, 3, 4. Then ABC. Is it visible? Nahi visible hai. Okay. अब ठीक है. अच्छा अभी इधर विजिबल नहीं है. अच्छा अब कुछ नहीं कर सकते. Okay. See, so this is the present pattern. See the way they are framing this question in something like, in one you will get some basic, very basic thing. Chandrayaan-2 is something related to space technology. These general things you know. Space technology is something application of physics. Very simple, you can understand. It is not application of biology or chemistry, application of physics. So a very simple definition. Okay, even from standard 6 or 7 NCERTs. Say for example like geostationary orbit. You can understand, matter of basic definition. Okay, so in the lectures I will be discussing these basics, but the thing is that this is the way they are asking the thing. So just before the prelims, in the year you are supposed to appear, before 1 to 2 months of prelims, just have a study of NCERT 6 to 10. Okay, just to refresh, all of you have studied till 10. Okay, study to be on the lines of basic definitions only. Clear? Okay, and NCERT is a matter of basic definition and basic knowledge. Okay, so this point is clear. This is the approach regarding physics and chemistry. You will not get any direct question from physics and chemistry. Okay, for example, I am taking one example of chemistry. If they have to ask you about, they have asked this thing ITER, International Thermonuclear Experimental Reactor. They will ask just a basic definition of enrichment. Now you can understand basic definition of enrichment from a standard 7 or 8 chemistry topic of NCERT. But their focus is to ask the technological thing. In one they can ask you the basics. Okay, this is the way physics and chemistry are covered in the prelims question. This is clear? Now I am just completing this, the way of asking the question. In 2 and 3, technical details related to the thing that is being asked. Clear? 4th, a general information. See the design of the question. General information to check those, say for example, someone who is having PhD in space sciences, okay, they know entire thing about something called Chandrayaan 2. But if they are not updated with some general ideas that mainly comes in the newspaper, India became 4th country, India became the first country in the very first attempt. These are what? Not a technical detail. These are the thing which is a general understanding must be there to every citizen even. So for you it is very important because you are preparing. You are getting this thing, okay? That is, they are, you can understand one thing, the UPSC experts just in one question have checked your entire basics, entire technical knowledge, and they had also checked you that whether you are studying newspaper or some ready-made materials. You are getting the thing, okay? This is the nature of the question that comes in prelims, okay? As I have said, around 15 to 18 question comes in prelims from this section. Almost all question are having this nature. They have changed the pattern only to ask the questions in multiple manner, so that in one question they can check your entire knowledge. This point is clear? Now the same is designed in 1 and 2, 1, 2, 3 and all this you can understand. Okay, now in biology, same way they are asking biology questions along with some questions of biotechnology, but 1 or 2 question every year they are asking from biology. Okay, 1 to 2 question. That too, as I have said, NCERT is a matter of basic definition. So they are asking even the basic definition, and mainly they are asking from the structure of the cell, something like mitochondria, endoplasmic reticulum. Okay, so the case is you will get 1 to 2 question from biology directly. It does not mean that only 1 to 2 question from biology. They used to ask even 3 to 4 question, but the other 1 to 2 question will be with the biotechnology part of science and technology. Okay, the same pattern they are also following in biotechnology. For example, have you heard about 3-parent baby technology? Anyone of you? 3-parent baby technology, very important for this year prelims. Okay, so this is a technology related to defects and disorders of mitochondria. Okay, biotechnology have successfully developed a technology that is also called as MRT, mitochondrial replacement therapy, for the default mitochondria. Okay, now you can understand. They will. It is a matter of 2015 and 16 because UK became the first country who legalized the same. Okay, so you can understand. They will take this from 2015 to 16. Okay, they will simply place consider 3-parent baby technology. First definition would be from mitochondria, is a matter of NCERT. This point is clear. Okay, so I think pattern regarding prelims is very clear to you. That is 15 to 18 question you will be getting from this. No direct question from physics and chemistry. Biology 1 to direct question along with the questions of technology. This point is clear. Any doubt in this regarding pattern? Now regarding mains, 6 to 7 question used to come, and the question are something, I'm just giving you some question ideas, like analyze India's space technology in the socio-economic development of a country. Okay, analyze nanotechnology for the development of socio-economic aspects of a developing country like India. You are getting this thing? How biotechnology can address issues of health related present concern, you can understand after COVID-19 and all. You are getting this point? That is, you will not get direct question like explain biotechnology. Okay, that is why they change the pattern. And analysis, analyze, discuss, critically analyze makes the question again a challenging one. Okay, so first thing is this, and second thing, the idea of answer writing is very much different as it is a technical paper. Okay, so the entire thing relating to this I'll be discussing in the main section. This point is clear. Now I'm restricting my discussion to prelims. Okay, now one important thing regarding books and all, you can understand one thing. When it comes to matter of technology, I am not referring any book to you because books are having limitation in terms of such subjects in UPSC syllabus. Okay, because you can understand, say for example, very recent launch of ISRO, something called Amazonia satellite. All of you might have heard. Okay, these are the things they are asking in this way in prelims. Okay, no book or no publisher is updating the book. They can't even on these lines. Okay, so there is a limitation of books of technology. Okay, so in this case I am just referring most important, and as the thing is very conceptual in nature, so the most important is the lectures. Okay, you have to very much focus on the lectures, concepts and all. If the, as many of you are from non-science background, so if there will be doubt, you can ask afterwards. Okay, I'll be here for a couple of minutes. Okay, you can ask about your doubts. The thing is that you have to very clear in the concepts, you can understand, then you will have a position that you can write about something like analyze space technology for social. It is your analysis. They are not asking ready-made things. This is clear. Thing is changing also in every mains. Okay. Second thing, in the prelim section, I'll be restricting myself to the objectivity of the syllabus, but in the mains, along with the lectures, I used to dictate the notes as well. Okay, but the thing is that the most important thing that is required about this section is to update. You can understand. For example, say by the month we'll have the discussion of mains. After 1 or 2, 3 months, say for example ISRO launch a mission. Okay, it means you are supposed to update my notes as well. Okay, because my notes in the market seems to again every year needs to updation. It is not like other conventional subjects, like once notes is there you can use for many years. This is the case. Okay, so I'm just referring class lectures, notes, and only one source for this section. Okay, that is the newspapers. Newspaper is the best source. You know why? Because this is the source of UPSC experts as well in framing the question. They are not referring the ready-made materials of markets in framing the question. They are referring these sources so that they can test your newspaper understanding by asking some general information. This point is clear. So I am not referring any book. At maximum you can refer the PDFs for a little bit better understanding of the thing. Okay, but one thing I am referring to have regular reading with you, that is the newspaper. Thing will be more clear after you will understand about topics. What is space technology, what is biotechnology and all. So this point is clear regarding pattern, syllabus and all. Any doubt in this? Okay, afterwards also you can start. Okay, so I am starting with this, with the first topic, that is the space technology. See, first understand regarding prelims, nature of question. Around 2 to 3 questions every year comes from this topic. Before starting the topic, I am just giving you the ideas of the nature of the question. Question mainly comes from Indian Space Research Program. Okay, I have divided the topic into various subtopics so that you can have a clear idea of the question area of the syllabus. Okay, so write the subtopics in the space technology. First, write basics of space technology. First, we'll be having the discussion of basics so that you can understand the higher things. Basics of space technology. Next, Indian Space Research Program. Indian Space Research Program. Under Indian Space Research Program, write 4 dimensions. That is, Indian Space Research Program is having 4 dimensions. First dimension, launch vehicle technology. Launch vehicle technology. Second, write like this. In the second, write INSET oblique GSET. Third, IRSS. Third dimension, IRSS. Indian Remote Sensing Program. Write in bracket Indian Remote Sensing Satellites. Fourth, space mission. Space mission. Okay. Next, write after 4th dimension, write the next subtopic, navigational system. Navigational system oblique positioning system. Navigational system oblique positioning system. Next, organizational setup. Next subtopic, organizational setup related to space research in India. Organizational setup related to space research in India. And write the last, space laws. Space laws. Okay, now first understand the topic. See, tick mark Indian Space Research Program. Indian Space Research Program. That is, the 4 dimension of Indian Space Research Program is mainly the question area. Every year, 2 to 3 questions from prelim, and 1 full length question comes in mains from this topic. That is Indian Space Research Program. But after independence, for the first time, Government of India has introduced a bill in Parliament relating to space activities, as ISRO had expanded its successes, very much remarkable successes in various aspects of satellite launches, missions and all. At the same time, by this year, okay, India is also working to expand the sector of space sciences for the private players. One exclusive organization, New Space India Limited, is established. So you can understand, as since independence, these 2-3 years are very much important. There is a law making procedure is going on in India relating to space technology. As this happened after independence for the first time, so in the present mains, I am expecting a full length question from space laws. Till the year, space laws was an unimportant topic. You can understand, this is the idea you are supposed to develop, okay, that as there was no role in India's in space laws and all, but now India drafted its own space law and it is bill is pending in Parliament. Okay, I have referred to the technical committees because scientists and technical committees have raised some objections, so the thing is going on. Okay, so now you can understand. So in the just tick mark space laws for the coming mains. Okay, it is important for 2 to 3 years till the time it will become an act. Okay. So now the point is very clear to you. Okay, that is main topic is Indian Space Research Program. Clear? Okay, now first I am discussing with the basics. As I have said, if the thing will not clear, just ask. Okay, because it is the section is something like if you'll miss something, okay, if you'll not understand something later, higher technologies, when I'll move on, the thing will become very difficult. Okay, now see, what do you understand by the word space? What is a space? Just tell me your understanding. What you understand? All part of universe. Okay. Okay, or any other idea? Vacuum. Okay, or any other idea? See, I'll come to this. The word technology is the application of physics. Okay, application of physics where? On space. Okay, now over a period of time when space sciences started, okay, very clearly space is defined to perform the technology. Okay, that is, space is above the earth's surface. Very simple. Above the earth's surface is a space, but in order to perform technology, it is defined. Okay, so I'll be coming to here. First, understand the meaning of this word. This word is having its meaning in application of basic sciences. Here we are concerned about a basic science called physics. Okay, so application of physics. This application is performed by two things. I am using two technical words. This will be clear in the later discussion. Launch vehicle and satellite. First I am explaining to you in a very general way what is it, then I'll explain in a short while the technicalities. Launch vehicle, from name itself is clear, a vehicle used to launch something. That something is what? Satellite. That is very simple. Say for example, this is a launch vehicle. You might have heard something called PSLV. What is PSLV? We'll see. So this is a launch vehicle. It takes a satellite, okay, places in the space. Okay. It takes a satellite, places in the space, in a particular place. Okay, in a particular place, that is a path that is called as orbit. Very simple. So what is orbit? Path of a satellite. Very simple. Launch vehicle takes a satellite, places into space, okay, in a path called as orbit. Path of a satellite is called as orbit. Now, from the space sciences, over a period of time with a vast study, it was defined that which all height are important. That is very simple. Which height are important for a particular application, because when we talk about application, there are many applications: television, telecommunication, agricultural related data, security information, intelligence information, disaster management information. These all are information coming from satellite. Okay, so for each and every application, over a period of time, it is studied that above the surface of Earth, which height is important for what. Okay, so above the surface of Earth, the path of a satellite is defined. Clear? Near to surface of Earth, the first path is called as LEO, low Earth orbit. Why low? Near to Earth. Okay, so write down this one, okay, along with me. Low Earth orbit. Okay, write in this up to 2000 kilometer, and in the bracket of 2000 kilometer, write like this: 600 to 900 kilometer, at maximum to 1000 kilometer. Up to 2000 kilometer, write in brackets 600 to 900 kilometer, up to 1000 kilometer. Okay. Now, above to this, at a height exactly 35,786 kilometer. Many book it is also given as like 36,000 kilometer. Okay. Write about this. Have you written this one? Now listen, see. In the entire universe, nothing is stationary. Even our Earth is not stationary. Okay. There was a space scientist, Arthur Clarke, who had given one concept. Okay. In his space sciences study, he had given one concept that from the surface of Earth, exactly 35,786 kilometer, it is the place. If something will be observed from here to here, or something will be observed from here to here, it seems to be stationary. It is not stationary. It seems to be stationary. This happens exactly at this height. As idea was proposed by Clarke, so also called as Clarke orbit. Okay, Clarke orbit. And what idea he presented? That it seems to be stationary. Stationary to what? Stationary to Earth. So it's called as geostationary orbit. Very simple. Geostationary orbit. Why? Because it seems to be stationary to Earth. Or in this term, also called as GEO, geostationary Earth orbit. Okay. Now, Clarke later proposed that as it seems to be stationary to Earth, it can better be used for the communication services, because footprint of the satellites from here to here will be exactly same the way Earth is moving. Once again I am repeating. Clarke later proposed that this orbit, as it seems to be stationary, is better for the communication services, as the footprints of the satellite from this point to here will be in accordance with the way Earth is moving. This point is clear. Okay. So this orbit is exclusively reserved for communication services. Now the communication services word, why? So here write in the bracket, exclusively for all communication services. Right here in GSO, exclusively for all communication services. See, underline the word all. See, why I have given you this word all? Because many a times, in order to confuse, UPSC experts places many examples, like DTH is placed in this, DTH, HDTV, mobile communication, 4G, whatever communication is there, it is under Clarke or GSO. This point is clear? So, all communication services. Okay. No need to write so many examples, just have in mind this now. So, this point is clear. Next, other than communication services, whatever idea comes to your mind, other than communication, clear? Agriculture, disaster management, search and rescue operations, natural resources data, okay, intelligence gathering information, you are getting this all information are informations other than communication. Technically, other than communication operations are known as remote sensing operations. So just have in mind one thing, okay? This is for communication, and other than communication, LEO. So write in LEO, come to, okay? That will be very clear in the later part of discussion, okay? Right? other than communication services in LEO. You are writing in LEO, other than communication services, write in bracket, remote sensing operations. And what is remote sensing? That will be clear in the Indian Space Research Program. You have written there itself, Indian Remote Sensing Satellite System and all. Okay. So other than communication, so many examples I have given. I'll be again giving so many examples when I'll be explaining about remote sensing separately. This is clear? Now, next. Till the time of 1980s, this was called as space in our space sciences. Very simple. Up to 2000 kilometer, best suitable for other than communication, and exactly around this height, best suitable for communication. Rest all are not having very much use for space sciences. It was the case up to 1980s. Okay. Now, above to this is of no use in practical applications. We are talking about practical application for humankind. Above to this, that is above to 36,000 kilometer, is a matter of research, matter of study of universe, analysis of cosmos, many high frequency waves. That is, above to 36,000 kilometer is a matter of what? Space technology R&D. This is clear? So above to 36,000 kilometer is called as HEO. Okay, so write in the chart HEO, high Earth orbit. High Earth orbit. Write in bracket above 36,000 kilometer. Okay. Right. Mainly used for space related higher research, space related higher research, comma, astronomical observations, astronomical observations, comma, geophysical studies, astronomical observations, geophysical studies, etc. Okay, till this it is clear to you. Now, there happened a development in the year 1978 by United States. Okay, that will be discussing separately. For that you need to understand some technicalities. Okay, you have written one topic, navigation system / positioning system. Okay, we'll see in detail about this very important topic. So by 1978, United States launched a system called navigation system, and there came a concept regarding a orbit. So thing is being updated. Okay, so there came a concept in between both. This is for other than communication, this is for communication. So there came a concept in between both. So it was named as MEO, that is middle. Okay, so write MEO in between, middle or medium Earth orbit, middle or medium Earth orbit. Okay, write its use exclusively for navigation system, exclusively for navigation system. Navigation positioning system, you understand, like GPS, GLONASS and all. Okay, navigation system. Write in bracket one important information and tick mark. This is important for coming prelims. Where you have written exclusively for navigation system, write in bracket Indian system is an exception and tick mark this point. Indian system is an exception. Okay. So just have in mind one thing. Whatever positioning system you know, GPS of United States, GLONASS of Russia, Galileo of European Union, okay, BeiDou of China, whatever be the navigation system of any country is launched where? MEO, okay. exception is India. We will see what is that exception. Okay, write the height of MEO in this way. Okay, it is up to 20,000 kilometer, but it starts from 5,000 kilometer to 12,000 kilometer and goes up to 20,000 kilometer. Write exactly like this: 5,000 to 12,000 kilometer up to 20,000 kilometer. Okay. Till this it is clear to you. Okay. See, this is the space. Now, here onwards, when I'll be saying the word space, this chart must comes into your mind. Then only you can understand the higher things. Okay. So whenever I'll say the word space, this is the space. Okay. And according to our technological need for applications, two important orbits are there. One is for communication, one is for other than communication. One newly introduced by the time of 1980s, that is MEO. Above to this is a matter of research. Very clear. Okay. So what is a space is now clear to you. Okay. Now we have to perform this with this two. We will see this in a short while. This is clear. Now I am coming to this point. Orbit is what? A path of satellite. Very simple. If it is a matter of communication satellite, we have to place somewhere here. If it is a matter of, I am writing S for satellite. If it is a matter of, say, a satellite for agricultural data other than communication, have to place here. Now, as Earth is moving, so this satellite will move in and around Earth, then only it can get the data. But there are two ways of operation of a satellite. That is why these two operations were divided. One is divided for exclusively communication and one is divided for other than communication. Okay, there are two ways. That is why this division is there. First way is when we talk about communication satellite. Okay, communication satellites follows Earth. It means what? Earth moves from west to east. So very simple. Communication satellite moves from west to east following Earth. Same was also proposed by Clark. This point is clear. Okay. Exactly opposite in this case. That is why communication and other than communication operation happens differently. In case of other than communication, that is matter of LEO, it follows poles. This point is clear. It follows poles. That is, it does not follow the west to east. Why poles? Very simple, you can understand. Because matter of remote sensing other than communication is a technique of gathering data which will be much more precise and accurate when the polar points and polar movements have to be followed. This point is clear. So, first thing, this is the space. Second thing I have discussed is this Clark orbit or the orbit exclusively for communication purpose follows the west to east movement. Other than this, that is LEO, follows the polar movement. This point is clear. Now, second thing, we have two ways, that is we have two options to place a satellite. Okay. Two ways is clear to you. One is west to east, one is polar. This point is clear. Now, there are two ways to place a satellite. Okay. First way was mainly used when our space sciences was started, somewhere around 50s and 60s. Okay. Now we have technologically become much more advanced, so we are mainly using the second one in the present day. Okay. But there are two ways to place a satellite. One is called as circular orbit. Okay. From the name itself is clear, that is circular in shape. Say for example, this is Earth and this is a satellite. Okay. Following a circular path. Following a circular path means, as you know, the radius of circle is same. So it means what? at each and every point the satellite will be equidistant from the earth station. This point is clear? Okay, now this was the limitation also in placing a satellite in circular orbit, okay, because when our technology get advanced, if say we plan to launch a satellite in a point very near to earth or in a point very far to earth, this is not possible here. Satellite will always be equidistant from the earth station, okay. So a second case, that is the elliptical orbit, okay. In this case it is in the form of ellipse. Now say this is earth, this is the position of the satellite, clear, near. When the same satellite will reach here, will become farther, that is in one complete orbit we will have two different options. One is near, that nearest point is called as perigee, farthest point is called as apogee, okay. Till this it is clear to you. So we have discussed what is space. We have two options in placing a satellite, one is circular, one is elliptical. This is clear. Now next, what is geostationary orbit is now very clear to you, okay. But when our space sciences get advanced, okay, I am going to use one word, synchronous. What is the meaning of this word? What is the meaning of synchronous? Simple English meaning. What is the meaning of synchronous? That is making in tune with something, okay. So when our space sciences get advanced, okay, there started need to place satellite in a particular orbit by giving some inclination. See, understand this point. Clarke proposed about geostationary orbit, that is orbit seems to be stationary from earth, okay. Now seems to be stationary means in entire launches of space technology, equatorial plane and orbital plane is the plane that is considered in terms of angle, okay. Now Clarke geostationary orbit, from the name itself is clear, something that is stationary to geo, that is earth, so it is called as geostationary orbit. This is the orbit at 0 degree inclination, okay, just above the equatorial plane, okay. When our system get advanced, there started a need to get high defined signals, present day HD signals, okay, to get more accurate pictures, more precise relay. There started a technique of giving some inclination to satellite. Say for example, this is a satellite at 0 degree, okay, geostationary. If say in the same orbit that was proposed by Clarke, if 2 degree inclination is given, okay, satellite is shifted a little bit eastwards to get better signal, because any country launches a satellite in and around earth, but the signals are restricted to the territorial areas of the country. Every country satellite is moving in and around earth, but if it is a matter of DTH of Indian satellite, DTH of United States satellite, the signal must be there for their territorial areas, land areas. So keeping in mind the advanced technology features in relaying the signals, data's enhancement capability and all, satellites are synchronized with earth, okay. Synchronized means now is in tune with. Why there arises a need? When our technology get advanced, okay. For example, we moved from one channel DD1 to cable television. Now the technology is much advanced that direct to home. Signals are directly related to the subscribers and they can receive directly with a smart card and decoder. No need to have any station on earth, likewise in Doordarshan or likewise in cable television time. You are getting this thing? So how the thing became advanced? When we started synchronizing these satellites according to our technological need. So synchronizing is making in tune with, in terms of inclination, in terms of shifting towards some direction to get more accurate and precise signals. Clear? When the same will happen for the communication system, okay, we will call geosynchronous orbit. Point is clear? When the same will happen for communication services, we will call it as geosynchronous orbit. This is clear? When the same will happen for LEO, what we will call? Just recall two ways, west to east in case of communication. So very simple, geosynchronous. But in case of LEO operation, it is a matter of pole. So in case of LEO operation, our advanced placement of satellites in terms of synchronization is polar synchronous orbit. Okay, polar synchronous orbit. This point is clear to you all? Okay. So geosynchronous is nothing, but we are talking about geostationary orbit. In many books, it is written interchangeably, but the thing is that geostationary orbit is at 0 degree inclination, but geosynchronous is in the same orbit. That is, if say this is a satellite in geostationary orbit, in the case of geosynchronous, even the satellite will be in the same path, but having a inclination. This is making in tune with geostationary. So we used to call as geosynchronous. If the same synchronization we will start in the LEO, that will be called as polar synchronous orbit. Now, just now I said countries launches satellites in the Earth orbit, but our requirement is to restrict the signals to the territorial limits. Okay, it means there is a requirement that the solar time of Earth related to a particular country must matches with the time of satellite. Then only in daytime we can get the better signals. You can understand this point? So when we synchronize the satellite in LEO, okay, it is polar synchronous. So in case of polar synchronous, when the same will be synchronized with solar time, so the same orbit will be called as polar sun synchronous orbit. This point is clear. Why? Because we have synchronized it with a solar time according to our requirement in the Earth station. Okay. Any doubt till this? Or is clear? Because now we are studying the basics. Okay. So in the basics, if there is any doubt, ask, because when I will move to the higher sections, if we will have the doubt, thing will be very challenging to understand. Okay. Or other doubt? One doubt, geosynchronous. See, Clark had given us the idea of geostationary. Very simple. He had proposed that, very simple, just above the equatorial plane, go to 35,786 kilometer. Things seems to be stationary and exclusively used for communication purpose. So it's called as geostationary orbit. From the name itself is clear. But when our technology get advanced, the example I had taken from Doordarshan, cable television to the present day DTH, even HD TV, okay, that is when our system get advanced, in the same idea proposed by Clark, we started placing the satellites in tuning with Earth, that is in the same path, at the same height. Satellites are tuned with Earth. Such tuning in terms of angle, in terms of direction, is termed as synchronizing with Earth. So, such orbits are termed as geosynchronous orbit. Okay? Okay. Or any other doubt? No doubt. Then I'll check by asking doubts. Okay. See, polar synchronous is clear to you. Till this is clear to you. Okay. Write about some basic definitions of orbit. Right. Prograde orbit. PRO. Prograde orbit. Orbit which is in tune with Earth. Orbit which is in tune with Earth. Okay. Can you give example? HEO नहीं. Simple. GSO, geostationary or synchronous. Write the example. Next orbit, retrograde orbit, RETRO, retrograde orbit. Orbit which is not in tune with Earth. Not in tune with Earth. Okay. Example. LEO. Okay, example LEO. Next, write non-inclined orbit. Non-inclined orbit. 0 degree inclined orbit. Non-inclined is 0 degree. Best example is? Very good. Geostationary. Okay. Next, write inclined orbit. Inclined orbit. Okay. Orbits having inclination. If inclination is low, is termed as low inclined orbit. And if inclination is high, termed as high inclined orbit. Write one example. Is important for prelims. That's what I had given this definition. Having high inclination is high inclined orbit. Okay. Write one orbit. Name of the orbit is a Russian word. Molinia. MOLINIYA. Molinia orbit. You are writing in the example of high Earth. It is highly inclined orbit. Molinia orbit. And tick mark. This is important. Right. Molinia is a Russian word meaning lightning. Molinia is a Russian word meaning lightning. Is discovered by Russia Space Agency. Discovered by Russia Space Agency. And is highly inclined. Write in bracket 63.4 degree. 63.4 degree. Okay. Mainly used for 63.4 degree, mainly used for space-based higher research study. Space-based higher research study. Okay. Till this, any doubt is there? Now I can move to the higher things, Indian Space Research Program. Okay, I am just summarizing the basics. See, in the basic I have just explained to you, there is two technical words that we will see now. Launch vehicle is something that takes a satellite. Okay, according to our technological requirement, two heights are defined, one for communication, one for other than communication. Later on, one more was added for navigational system, and above to this is a matter of research. Okay, there are two options. Okay, we can place a satellite, and there are two ways. One is prograde, one is retrograde. This is clear. Then we have seen about some basics orbit. Okay, now I am moving to Indian Space Research Program. So now onwards, whenever I will say the word space, that chart comes into our mind. Okay, now see, Indian Space Research Program, first understand some basics, background behind this. Just after the independence, when Britishers were there, Britishers were also using some of the communication system, okay, some of the remote sensing system, but thing was not systematic. They were following the way, like they were taking some satellites, say from UK, taking some launch vehicle from Soviet Russia. Somehow they were following the space technology measures. Okay, just after independence, Dr. Vikram Sarabhai, who is known as father of Indian Space Research Program, he drafted a plan. Okay, and he started working on the plan in his hometown Ahmedabad in the independence year 47. Okay, he conveyed the same to the government of India, but government of India delayed, and by 1962 a committee was constituted to look into the matters of the draft submitted by Dr. Sarabhai. Meanwhile, from 47 to 62, Dr. Sarabhai, with his own efforts along with some research scientists and all, started the space program. Clear? As I have said, in his hometown. Later, government of India taken many acres of land and converted near to Ahmedabad the area into PRL, Physical Research Laboratory. Today, PRL is one of the leading institutes in research sciences in space technology. This is clear. So systematically, there started work after 1962. Okay, and the committee name was INCOSPAR. Okay, Indian National Committee for Space Research. Indian National Committee for Space Research. And Dr. Sarabhai was made the chairman of this committee. And Dr. Sarabhai's draft was studied at a great length. And by 1969, this committee submitted its report. Now you can understand, around 20 years delay in starting the program. Okay, and that is why ISRO's success is very much remarkable. That is, technically it will be clear from the discussion. ISRO started working with high technological measures mainly after 1993. So just after 1993, in this 2 to 3 decades, a space agency which just started work mainly after 1993 with a high technology through outputs is now in a position that is competing with the esteemed space agencies, NASA, ESA and all. That is why ISRO achievements is very much remarkable. Okay. So by 1969, this committee submitted the report. There were many recommendations, most important two you are supposed to know. First, this committee recommended to Government of India that, keeping in mind the technicalities of space sciences, there must have a dedicated space agency on the lines of NASA, on the lines of Roscosmos in India as well. Government of India accepted the recommendation and ISRO came into being as a dedicated space agency to start Indian Space Research Program. Okay. Second, the committee proposed to, regarding the objectives of this program, as socio-economic development. That is, space technology objective will be mainly towards socio-economic development of the country. This point is clear. That is, this thing was specified, and even Government of India in the present law making procedure that is going on is considering the fact that even in 1969 our space scientists recommended that not to divert our technological measures achievements like developed countries, because today when we talk about developed countries, their defense agencies maintain their space sciences. Okay? Almost in all developed countries, their defense department handling the space sciences. Government of India clarified that space sciences will be meant for socio-economic development of a country, okay, that just got independence in 47. First thing. Second thing, regarding defense sciences, it is the case in India only. It was clarified that regarding space sciences, a dedicated agency ISRO, regarding defense sciences, a dedicated agency DRDO. Okay. So, as India's objective is on these, and this is the case, you have written in the navigation system, India is an exception. Thing will be clear, because India's objective in space sciences is on these lines. This is clear. Okay. Now, keeping in mind with all these objectives and all, Indian Space Research Program was started in 69, and ISRO as a dedicated agency came under Department of Space in 1972. So, technically by 1972 ISRO started its work. This year is important, I will be referring here and there. Okay. So, background is clear. Okay. Again, in the main section I will be dealing with the background in a little bit more detail, because background is important in the mains answer writing. Okay. So, basic background is clear to you. 62 committee, recommendation 69, 2 important recommendation, and by 72 ISRO started the work. Clear? Now, by 72 when ISRO started the work, Indian Space Research Program was having 3 dimensions. You have written 4, initially it was 3. Okay. Now, in order to start this program, the first requirement is what? Launch vehicle. Very good. Okay. So, first dimension is launch vehicle. In order to have launch vehicle, we need to have what? Technology. Then only we can develop launch vehicle. So, first dimension is launch vehicle technology. Clear? Second and third dimension. Second requirement is satellite. There are 2 types of satellite, we know. One is communication, one is other than communication. So, exclusively for communication purpose, India's dedicated system is called as INSAT. Now, write the full form also. Indian National Satellite System. Write INSAT. Indian National Satellite System. Okay. Now, write in bracket. Present day GSAT system. It is started after 2001. Okay. In the same discussion we will see. Present day GSAT system. Write one more point in the bracket. Exclusively for communication system. Exclusively for communication system. After present day GSAT system, write in bracket exclusively for communication system. Third, you have written IRSS, Indian Remote Sensing Satellite System. Indian Remote Sensing Satellite System. Write in bracket, other than communication services. Other than communication services. Okay. Now, just understand one thing. From 72 to year 2008, okay, ISRO started working on the research program. By 2008, ISRO achieved so many remarkable successes and all. So, by year 2008, fourth dimension was added to it. Okay, so right here, fourth dimension, right in bracket, year 2008, space mission. Okay, now this is clear. So initially it was 3, now it is 4. Clear? Now one by one I am starting the discussion with launch vehicle technology. Now, as I have said, this is the most important question area. Okay, even a particular thing can be asked as a short note. Explain launch vehicle technology, analyze launch vehicle technology in the development of space technology and all. The expected question I will be giving you at the last in that discussion of mains, but just I am giving you overview. So now first understand launch vehicle technology. Okay, is a little bit technical. If the thing will not clear, just ask. See, ISRO started the work by 1972. Now, when we talk about any vehicle technology, okay, it is a matter of what? Engine. Engine makes a vehicle different. Okay, say for example cars. Cars have to perform a horizontal motion. It is the engine technology that makes a difference in the cars when it comes to horizontal motion. Likewise, it is a vertical motion. Okay, difference here is that unlike horizontal motion, we have to cover the entire distance in one go without rest. That too not so near, somewhere around 2000 kilometer, somewhere around 20,000 kilometer, somewhere around 36,000 kilometer. These three are the most important requirement. Rest all are the matter of research. Okay, so engine technology is the main technology in launch vehicle. Okay, so I'm explaining about engine separately because it's important for prelims and is important also for short note. It is asked as a short note also in mains. This is clear? Now, engine technology. The year ISRO started the work, that is by the year 1972. Okay, only one engine technology was in the knowledge of ISRO, that is termed as solid. So write about engine separately. Okay, solid engine technology. See, you know the fuels used in launch vehicles? Which fuel used in launch vehicle? Like petrol, diesel is used in horizontal motion case, cars and all. What type of fuel used in rocket engine? That is a matter of spacecraft. Important information for prelims. Okay, one by one we will see. Okay, see, and the most important thing in the development of technology is that you need to understand the decadal development. That's what I am starting with year 72. Okay, the year 72, when ISRO started the space research program, one type of engine was in the knowledge of ISRO. Okay, one comparative analysis just have in mind. We are talking about ISRO of 1972. It is a matter of start, but by 1972, NASA, European Space Agency, Soviet Space Agency were even performed very high technologies mission. So you can understand, solid engine was a basic technology, new for ISRO but outdated for them. Okay, for them there was something new that we will see. Okay, so solid engine, why the name? Because the fuel used in this engine is solid. Very simple. That is why such engines are called as solid engine. Okay, now there is a chemical compound HTPB. Okay, such informations are important for multiple or prelims. And oxidizer, oxygen. So write some point about solid engine. Solid engine uses fuel. Write the name of fuel, underline this. HTPB, capital words. Write the full form. hydroxyl terminated poly POLY butadiene, hydroxyl terminated polybutadiene, BUTADIENE. Okay, is the name of the chemical compound. Okay, and oxidizer oxygen. Now see, any engine is having fuel and oxidizer is the main technology. Now see, by 72 it was in the knowledge of ISRO. With the use of solid engine, ISRO started the first phase of launch vehicle technology. Okay, first phase was declared completed in 7 years, that is in the year 1979. Okay, so in this 6 to 7 years, ISRO worked with the solid engine technology and designed a launch vehicle and was named as SLV, Satellite Launch Vehicle. Okay, draw along with me. Is a launch vehicle of 4 stages. S is for solid engine. Okay, write its full form, Satellite Launch Vehicle. Okay, and write one, after drawing, write one line. 4 stage, after drawing, write 4 stage solid engine based, 4 stage solid engine based propulsion system, propulsion, PROPULSION, 4 solid engine based propulsion system launch vehicle. Okay, launch vehicle. Now listen, it was completed by the year 79. In order to test SLV, what is the requirement? One satellite is the requirement, then only we can test a launch vehicle. So one indigenous satellite was developed. Okay, that is called as Rohini. So write रोहिणी सैटेलाइट. ओके, हाँ इसी में लिखना है फेज 1 में, रोहिणी सैटेलाइट. नाउ अंडरस्टैंड वन थिंग, यू माइट हैव हर्ड अबाउट आर्यभट्ट सैटेलाइट. आर्यभट्ट इज द इंडियन फर्स्ट सैटेलाइट, बट रोहिणी इज द इंडियन फर्स्ट indigenous satellite under Indian Space Research Program. So if the same will come in multiple, as Aryabhat is Indian first indigenous satellite, is wrong. Okay, under Indian Space Program, what is the Indian first satellite? Rohini. Okay, Aryabhat was launched from the foreign launch vehicle. Okay, now listen, see, any launch vehicle efficiency decided by the 2 parameters. Very simple, how much height it can achieve or how much weight it can take. Very simple, how much weight it can take, that is technically called as payload. Okay, and how much height it can achieve. Height is very clear to you. Our requirement is what? 2000, 36,000, in between 20,000, rest all above. Okay, now SLV was successfully tested with Rohini. Test was successful. India's first launch vehicle test was successful. Now, when height and payload was checked, it was found that height achieved approximately 500 to 600 kilometer. Payload approximately 40 to 50 kg. You can understand the limitation. Even there happened challenges in LEO. See. Okay, so write height and payload. Height 500 to 600 kilometer approx, payload 40 to 50 kg. Now you can understand, after 1979 test, still the limitation was there, but whatever be the case, ISRO successfully developed the first launch vehicle of India and was successfully tested as well, and phase 1 was declared completed. Okay, but no benefit from phase 1 as a still dependency was there on the foreign launch vehicles for the launches. Clear? Now, second phase was declared. In the second phase, see, first understand then write. In the second phase, already tested SLV, a decision was taken that already tested SLV to be improved, okay, in terms of stages and all. So SLV was improved and named as ASLV, okay, augmented, and augmentation is what? Simply improvement of the previous, okay. So write ASLV, write the full form, Augmented Satellite Launch Vehicle. Augmented Satellite Launch Vehicle. Now, see, what happened in this augmentation? One more stage added. So previously 4 stage, now 5 stage. Okay, so draw 5 stage. Five stage, okay, and 2 boosters were added. Boosters are low capacity solid engine, that is why I have written S, okay. It is just giving a, first draw this one, then write. Okay. Now see, say for example this is a launch vehicle, okay. Engines work in this way. First, it will start with the first engine. It will go say around 100 to 150 kilometer. This work of engine is over. Now it will shift to the second. It will take again to say 200, 300 kilometer, over. Third, fourth, fifth. Okay, now boosters are just added. It is something like, say, you have to go from here to here and someone pushed you. It means what? You will just immediately cover some distance, okay. So booster is same. When the launch vehicles have to leave the launch pad, boosters are triggered, okay. Sudden boost. In the sudden boost, even 100 to 150 kilometers are achieved. So boosters are added, okay. So write the point. 5 stage solid engine based, 5 stage solid engine based propulsion system with, write the name of the boosters, with strap on booster, write like this, strap on booster, with strap on boosters, okay. Now see, to test the ASLV, a decision was taken to upgrade Rohini satellite in a series. Already tested Rohini was upgraded and named in a series SROSS, Stretched Rohini Satellite Series. So write for satellite SROSS, Stretched Rohini Satellite Series. Okay, now listen. Work started from 1979, okay, and it was successfully completed by the year 1988. Okay, so within this 8 to 9 years, ISRO successfully developed the next launch vehicle, that is called as ASLV, and SROSS satellite series was launched with ASLV. Okay, now see, in 1988, again the test was successful. Okay, now in the successful test, again it is a matter of height and payload check. Now when height was checked, it was found out that it can go to LEO. Till LEO, this augmentation can help to reach to LEO. Clear? Now there happened 3 times increase in the payload, approximately 150 kg. Okay, so write in height up to LEO, okay, and write in payload approximately 150 kg. Clear? Now, by 1988, one thing was very much clear to ISRO facilities, that at least LEO operation can be performed by our indigenous launch vehicles, that is called as ASLV. But you can understand, no development of such launch vehicles to go to GSO, GEO, MEO or say HEO, no development, but at least this was developed now. Why this was so? Because solid engine capacity is not having on these lines that it can go to the higher orbits. It was known to ISRO, but as the technology was not available and was the time of Cold War and all, so India, this developed or declined India of any such help in the technologies and all. So it was a limitation. Already India, you can understand, Indian space program was delayed. So decision was taken that whatever is available with us, just start. This was the case. After 88, now it was very clear, no further augmentation in solid engine, because generally 3 to 4 stage are the maximum stages, here 5 stage. Okay, now, so by 1988, it was the requirement of the most advanced engine of the time. Today something advanced is different, okay. That is by the year 1972, when ISRO started the work, I have already said there was something very advanced that was known to handful of 3 to 4 developed nations. They declined India any such help on the same. Clear? Now, but by 1988, no option. Okay. So, by the time India started its space program 1972, it was very clear to space scientists that without the advanced engine, an advanced engine of that time was known as liquid engine. Okay, the time of 1972. Clear? As no country agreed on the same, so somehow Government of India convinced, here it is visible. Okay, I am writing here. Second one, I am writing the second engine. So by year 1974, somehow Government of India convinced France by 74, okay. But the agreement that was made, known as TTA, Technology Transfer Agreement, this agreement was made by France, and it was defined that only it is a matter of R&D, no commercial test or no commercial use. Clear? So by the year 1974, you can understand, already agreement was made with France under TTA, Technology Transfer Agreement, but agreement was made exclusively only for R&D purpose, not for commercial launches or test. Clear? Under this agreement, India received the liquid engine technology, and in France it is called as Viking. Okay, Viking is the French name of the liquid engine. This is clear? Now you can understand. By 1974, Government of India made available to the space scientists the liquid engine for the R&D purpose, but it had taken somewhere around 1990s time. You can understand, 15 to 16 years it had taken to develop the engine in its technology, in its design, in its development. It had taken this much year, okay. And by 1990s, ISRO successfully, that is India successfully developed liquid engine technology, okay. Name was changed from Viking to Vikas. Okay, have you heard Vikas engine? Very much important question for prelims, okay. There was a news also recently, like recently ISRO had improved the Vikas engine for the upper stages in GSLV, okay. So That's what I said at the very first. When you'll understand the things, thing will be very clear when you read the things in newspaper afterwards. So by 1990s, ISRO successfully developed the liquid engine technology in India. Clear? Now, what is liquid engine? Again, why is called as liquid engine? By different names in different countries, but is a liquid engine technology because same fuel used is of liquid in nature. Okay. The chemical compound used here is, so write about the fuel, an oxidizer. Fuel, the chemical compound is UDMH. Have you heard this fuel? Oxidizer N2O4. Different oxidizers. So write about liquid engine fuel UDMH, unsymmetrical di, unsymmetrical dimethyl hydrazine, unsymmetrical dimethyl hydrazine. An oxidizer used is N2O4. Okay. Till this it is clear to you? Any doubt till this? Till this we have discussed. 2 phases was completed in India with the help of solid engine. There happened agreement in 1974, but by 1990s we came to know about something called liquid engine technology and was renamed in India as Vikas engine. Okay, is a liquid engine which uses UDMH as fuel and N2O4 as oxidizer. This is clear? Now, with the help of this liquid engine technology, now phase 3 was declared and was declared completed in the year 1993. Okay. Now just recall, what was the important objective of INCOSPAR? One ISRO and one is socio-economic development. When we talk about socio-economic development, you can understand it is a matter most importantly other than communication. You can understand other than communication, and other than communication, what sort of uses? Agriculture, resources, land mapping, forest surveying, this all. Okay. Other than communications orbit is LEO. Okay. What kind of operation in LEO? Polar. Okay. So keeping in mind India's requirement in the objective, it was named as Polar Satellite Launch Vehicle. Why the word polar? You can understand, because our objective in terms of socio-economic development is mostly in the polar orbit that is related to LEO operation, that is other than communication services. This is clear? Now, PSLV was designed, and you can understand one thing, since 1993 to present date, PSLV is the most important launch vehicle of India. नहीं विजिबल है, पहले ना बताना था. Okay. I think one question is coming to mind, why solid if we developed liquid? Is it? See, solid was used because liquid engine is very high capacity engine. Okay. It can take in one go to higher orbits. Okay. So in order to make safe the launches so that it could withstand the high extremities of temperature when liquid engine would get heated. Okay. That is why start was made with 6 strap-on boosters, first triggering boosters. Okay. Second, we have to count this first, second, third, fourth. So after triggering the booster, it will shift to first stage solid. It will go in a very slow motion. Covers is somewhere around 400 kilometer. Okay. Suddenly, liquid engine, that is the second stage, would start. In a very fast movement, it can cover even 3,000-4,000 kilometers in a seconds. Clear? Again, engine would come to rest. Entire vehicle would come to rest, then solid. Then again, a very slow motion, 40-50 kilometers. And finally, it will switch to the last stage, and which is very much important because the last stage ensures the Earth station that the satellites are successfully placed in its destined orbit. Okay. Now, so PSLV was successfully developed. Okay. Now, one thing, the most important regarding its height and payload, it was tested with a dummy satellite. Okay. Now, so first understand one thing regarding its height and payload. It was observed in PSLV that when it comes to low Earth orbit operations, okay, such launch vehicles which are having liquid engine as the propulsion system, in terms of low Earth orbit operations, okay, it can take even payloads in tons, 1 ton, 2 ton, 3 ton. It is up to us that how we design according to our requirement. Very simple. Okay. Developed space agencies are having commercial launches, for example, Ariane rocket of France and all. Our objective is not commercial. Our objective is to perform socio-economic development. So, for our case, 1 to 1.5 ton is maximum. First, I have talked about low Earth orbit operation. Second, we have a second operation very important, that is communication services, GSO. In case of second operation, it can go to the higher orbits, but the moment liquid engine is used to perform the high Earth orbit observations, the payload reduced drastically. A 1 ton launch vehicle, if it is planned in low Earth orbit operation, will reduce to 100 to 200 kg around communication services operation around GSO. You can understand the limitation. That is, when it comes to LEO, it can take payload in tons. Okay, I am writing the Indian case. Our case is maximum interest of 1500 kg present day. Clear? But when it comes to GSO or GEO, limitations. Okay, 100-200 kgs are not enough, because generally what happens, the communication satellites are much more heavier than the satellites meant for remote sensing purposes. There is a technical reason behind this, because communication satellites are having many transponders, okay, for different signal relays, amplification and all. So, communication satellites are very heavier in comparison to remote sensing. Okay. So, you can understand limitation. So, we can say one thing, that is why its name was named as polar. Okay. So, one thing was clear, that PSLV type launch vehicle will be very beneficial for a developing country like India, keeping in mind the objective of space technology of India. Okay. But still the dependency was there regarding launches of communication services, satellites to GSO or GEO on foreign launch vehicle. You can understand, still the limitations was there now. But LEO operation limitation was over. Clear? So, a decision was taken in India, and Government of India allowed ISRO to develop PSLV in 3 different versions, because one launch vehicle cost hundreds of crores in its manufacturing and development. Okay. So, PSLV was developed in 3 versions, right? This one, PSLV CA, PSLV G, right in bracket STD, also called as standard, and PSLV XL. Just write one line, then write PSLV has 3 versions. Okay. Have you written this one? Most important thing. Okay. LEO up to 1500 kg and GSO just put a cross mark. PSLV CA, right in bracket of CA, core alone. Core alone. And just understand one thing. CA is the basic version which is not having boosters, only core. So it's called as core alone. Okay. So write in the bracket of CA, no boosters, only core. Okay. Standard G is for generic version, STD for standard. Okay. Just understand in this way. Standard and XL is this one, having 3 boosters to both the sides, but standard is basic in comparison to XL. That is, if there happened a launches around 500 to 600 kgs, standard are to be used. If there happens a launches more than 1 ton, XL. Okay. Now, I have reached the discussion till 1993. Okay. Since 1993 to present date, I am just giving you one data, I will be referring here and there. As India's objective, for India's objective, PSLV type launch vehicles are best suited. You can understand socio-economic development and all. So since 93 to present date, okay, more than 90% of launches of ISRO is carried out by PSLV. Okay, more than 90% launches since 93 to present date. Among 80% launches, more than 99%, almost all happened with XL. Clear? So this point is clear. That is why PSLV since 93 to present date is the most important launch vehicle for a developing country like India, keeping in mind the socio-economic development aspect of the space technology. This point is clear. But by 1993, one thing was also clear in the technological arena, that still the dependency regarding communication services was there for the foreign launch vehicle. It is the case in 1993 for India. I am just taking a case, what sort of issues were faced by NASA and developed space agencies in the time of 1990s decade. Now, they had reached to a very developed stages in terms of space launches. They were planning in such way. We were struggling with GSO and all. They were struggling in this way. Say for example, if we want to go 1 lakh kilometer with 5-ton payload, you can understand. They were struggling on those lines by the time 80s, 90s. That is, by the time they are working on such an engine technology that can take 5-ton, 6-ton, 10-ton payload. Today, France, this Ariane rocket and all, is having 27, 28-ton payload capacity. They were working on these lines by the time of 80s and 90s to overcome all limitation in terms of distance, in terms of height and in terms of payload. Okay. Such things could not be completed with the help of liquid engine technology. This is clear? Okay. Now come to India's case. By 1993, in terms of ISRO's development, ISRO was struggling with such an engine that could take heavier payloads to geostationary or geosynchronous orbit. Clear? Now, there happened a development. So, I have discussed 2 types of engine. Now, I am discussing the third one. There happened a development in the decades of 90s, and since this development to the present date, this is the most advanced engine technology till date in launch vehicle technology. Okay. Such engine is called as Cryogenic engine. Have you heard this? Cryogenic engine. What is cryogenic engine? Very good. See, first understand its concept. Cryogenic is a concept in sciences. What happens in this concept? So first I am explaining to you cryogenic. Okay. In a temperature range from minus 150 degrees Celsius to minus 273. See what happens. When we study this scientific phenomenon, we have three states of matter. Okay, solid, liquid and gas. Okay, just take this case, this lecture hall. Okay, three type of states of matter are there. Okay, now there is a concept that is cryogenic. In this concept, if any scientific phenomenon is placed in between these temperature ranges, states of matter will start changes. That is, liquid starts converting into gas. Okay, liquid to gas, gas to liquid. This is clear? For example, in this liquid will starts taking the shape of states of matter as a gas. Okay. There are different liquids, even those liquids freezes also, but most importantly, liquid gets converted into gas, gas to liquid. Most importantly, these two. This concept of science is having many applications. You might have heard cryosurgery, cryomedicine. Even in cancer treatment, this type of surgical procedures are followed. There are many applications. For the first time in the decades of 90s, Russia successfully developed the concept of cryogenic science in rocket engine, that is called as cryogenic engine. Okay, that is a special. And one more thing you can understand, as states of matter gets changed, so one limitation, that is each and every material which is to be used within such extremities of temperature to be of very special qualities. That is why since the time to till date, these engines are very much costly in its development as well as in its maintenance. That is why is also a challenging for a developing country like India, and this is also one of the reason why PSLV is the most important launch vehicle for us. In many of the cases, even it is better to have a commercial deals, and India is having a commercial deals with France Ariane rocket. So it is better to go with those rather than to have a fully this maintenance of cryogenic type system. But as it is a matter of high technology, so we must have. So by the time of 1990s, technique was successfully developed. Government of India made an agreement here with Russia. Okay, and under this agreement, there started a program in India that is called as CUSP, Cryogenic Upper Stage Program, to develop cryogenic engines in India. Okay, now see, what type of engines are this? In this engine, fuel and oxidizer. Class is still 115, na? Okay. Fuel and oxidizer. At around minus 273 regarding fuel, see here, at around minus 253 degrees Celsius, hydrogen gas, okay, converts to liquid hydrogen, which is used as fuel. Okay. Oxidizer, approximately minus 186 degrees Celsius, oxygen gas converts to liquid oxygen, is used as oxidizer. Okay. So just write about cryogenic engine. First point, write in cryogenic engine. Cryogenic is a science. Cryogenic is a science pertaining to very low or super cool temperature, very low or super cool temperature. write in this line, in the bracket, this temperature ranges. In the line, write in bracket, this temperature ranges. This is the very low or super cool. Next point. Cryogenic engine works under the ranges of this temperature, and uses liquid hydrogen as fuel, and liquid oxygen as oxidizer. Liquid hydrogen as fuel and liquid oxygen as oxidizer. Next point. A special class of materials, pumps, 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 wires, etc., are used in the design and development of such engines, to withstand such low temperature, and write one more line. India started a program, write the name of the program, CUSP, underline this program, CUSP, Cryogenic Upper Stage Program, for the development of cryogenic engines in India, for most advanced launch vehicles, write in bracket GSLV, which was successfully developed in year 2001. Okay, just give the heading phase 4 GSLV. Tomorrow when I'll come, just recall me, I have to start from phase 4. Okay, and now just do one thing, just after the class, okay, just revise the things. If there will be any doubt, first tomorrow we'll discuss the doubts, then we'll start the session. And just do one thing, try to be regular, okay, because if you'll miss 1 or 2 classes, it will be very hard.